Hello and welcome. My name's Derek, and today we're going to be learning how to do a conceptual site plan and model inside Revit using the massing and site tools. And we're also going to extract out XYZ coordinates out of Google Earth to use as our base to create our massing model. And then we're going to add walls, roofs, windows to the massing and see how they work together. So this is the site we're going to be developing right here. And if you click on these place marks, you can actually put points on your site, which will give you elevations and coordinates that you can use and extract out as a KML file later and use into Revit. And I'll show you how to do that. So let's just go ahead and create some points. Now you'll see that you need to go ahead and click on local KML file. This is the file we're going to be extracting out. Okay, and I like to name these just to keep track of them. Okay. I like to pick the corners of my site. And let's pick a few down here by the road. And maybe a few more on the interior of the site. Okay, now what you'll see is this file that's being generated over here, over to the left. It's storing all this information. So if you drop this down, you'll see all of our points that we've just created. And you click in these, it'll actually give you information about each of the points. And you could turn them off, turn them on, or you can come in here and edit the points as you need to. You can also fly to these points. And what we're going to do today is we're going to extract these things out and be able to use them in our Revit model. Okay, so to be able to extract them out, you want to come over to this where it says Untitled, click on the little dots here, and scroll down to where it says Export as KML file. So let's go ahead and find our KML file. It's going to save it in your downloads. So go to your downloads folder and you'll see it's called Untitled 5. I've created a few of these, but yours will just be called Untitled. Now, the question is, how do we create that points file from Google Earth? Well, we've already created the KML file. Now, the next step really is to convert it. Now, there's a couple ways you can do it. And the most layman way to do it is you can open it up with Notepad. And you can go down through each of these points. Now, this is a little bit archaic because you can't really tell what's going on, but it's pretty simple to read if you kind of just understand the formatting. Each point's going to have an ID, and as you remember, we created and named them from before, but it's going to put an ID number with what we named it. If you come down and look where it says placement mark ID, and right below that there's our S1. Okay, so now you can kind of understand where the S1's coming from, and it's giving you points in longitude, latitude, and altitude, which is elevation. And so there's our S1 point, here's our S2 point, and as you go down further, you'll see all the points. Now, what you could do is you can simply go to these points and you can copy and paste this information and convert it from longitude to easterly or westerly, northerly, southerly, XYZ points. And that conversion is not very easy to do. I have to understand how to convert it. So I've developed a little cheat program that will extrapolate the information out of these files and create a points file that you can bring into Revit. So let's go ahead and go through that exercise. I'm more than happy to share this program that I've created. It's a nice little slick tool. There are some programs that have been out there to generate information out of Google Earth, but unfortunately some of them have not worked as well, and the API for Google Earth hasn't been as an open source for a lot of people to develop the connection between Google Earth and Revit that I've found. And maybe there's some new tools out there, and I know that there's some third-party programs that will do it somewhat too, but I just need it to be able to pull out these coordinates and do a simple massing model with it. So what I'm going to do is go ahead and open up my little program. And you'll see a welcome to menu. You just go ahead and click on start. And then there's two formats. The TXT format is an option to where if you wanted to copy over coordinates directly from Google Earth and paste them into a text file that's comma delineated, you could do that manually. And the format to create points file, you can Google that and you can look to see how Revit formats the points file. So you can do that all manually that way, and what it does is it converts the longitude, latitude coordinates into X, Y, and Z coordinates that Revit can read. Or you can simply just bring in the KML file that Google Earth creates. Okay, so we're going to go ahead and click on that and go to the downloads folder, where is the default for Google Earth to save the KML files. It'll be called Untitled. Yours won't have the 4 after it. I just have done this a few times, so it's renamed at number 4. And you go ahead and bring it into the program, and it's going to want a place to save the points file. So let's just throw in our desktop for now, and we'll call it points 01. Okay, now it says it's created it, and units are converted to feet. Okay, so just hit OK out of that, and you can close this dialog, and you're finished. Now the next step is to simply go into Revit. So we're going to open up a new project template. So just go under your models to your templates and click on New. And I'm simply going to do a architectural imperial architectural template, not structural, architectural, and hit OK. And we're going to start by going to our Massing and Site tools. Before you do that, you may want to switch over to a site view as we're working between level 1 and site. And you'll see that under the site view, it actually gives you the little icons that represent the survey and base point icons that we can adjust later. Okay, go up to Massing and Site, click on TopoSurf, click on Create from Import, and then specify points file. Okay, since we've stayed on the desktop, let's go ahead and find it. Points 01. I've got a couple different versions here. Just click the one that you created, and it's going to automatically format it for feet. You do have options to do different types of metrics. Okay, it's going to give you a message that you can't see it in this view, only because the elevation it brings it in at is not the elevation that this view is at. So it's in here. Just go ahead and click on and finish the program. Now if you want to see it, you can just click to a 3D view and you'll see it in there. So there's the 3D TopoSurf, and then you can see that my coordinates are way, way, way down here. Okay, so what I like to do is I want to fix my coordinates. So I want to adjust my coordinates to work with where my my TopoSurf is. Let's say you've already modeled something on here and then you fix your coordinates later. Then instead of trying to grab the model and the TopoSurf and bringing it down to this elevation, it's better just to adjust your coordinates to bring up to what you've already done your model at. Otherwise, you're going to get lots of errors. At this stage, you really could do it either way, but let's do it the way that I like to do it. So we're going to go to a north elevation, and you can kind of see here's my toposurf, and way down here are my coordinates. Okay, so what I like to do is I want to bring everything up. So first of all, I'm just going to bring these elevation datums up. And let's say you don't know where your level 1 is yet. It's fine. Let's just put it above, somewhere above our toposurf. Maybe bring it down just a little bit. And we're going to be designing this and trying to play with how we want to build the site. And you'll see that level 1 right now is 6,005 feet. So if you want to display this, normally architects like to show your level 1 at 100 feet. Kind of an industry standard. So let's go ahead and adjust that. So basically, you're going to want to go down to the reveal hidden elements and zoom way out, and you'll see that they're way down here. Okay, let's go ahead and grab these, both of these. There's actually two in here. There's one that's the survey, which is the circle. I mean, that's the base point is the circle, and then the survey point is the triangle. You have to toggle through it with your tab, and you'll see that the survey. So we're going to grab both of these and move them up. Now, is it important where you locate these? Well, yes, it is, but for this exercise, we're going to set it to our level 1. Okay, and if you need to adjust these later as you're designing, you say, hey, you're working with some grading and your civil engineer is saying, hey, your first floor is going to be higher to meet the grading. You can do the same exercise again and adjust these, but you always want to make sure that you're not moving your model, that you're moving your elevations and your base point and survey point relative to the model. So let's say you want to make this 100, then you can come in here and grab the base point, and if what happens is if you start to move it, you'll see that it actually starts to adjust the elevation. So let's set this at a -100. And then what you'll see is that this becomes 100 level. And that's a good point to start with doing your massing. So let's go ahead and close out of the hidden reveal elements and start looking at the massing. Let's switch over to the site plan. Now you can say, well, this is a great toposurf, but what do these boundaries mean? Like, how do I understand where these points are relative to my site? Well, what I like to do is go back to Google Earth, switch over there, and bring in that information that I had in the KML file, and do a little snippet image of that and bring it into Revit. Okay, I've opened up Google Earth Pro. I decided to use the installed version of Google Earth instead of the Google Earth web browser. And it's a free version that you can install directly on your desktop. And it gives you some more abilities to be able to extract files and more information for graphics and tools that you can use for presentations. And you can also bring the KML files in that you created before. So let's go ahead and try that. We're going to go to File, Open. Go ahead and browse for your KML file that you created. When you open it up, you'll see that it'll pop the points in the same location. Okay, and you'll notice that Google Earth Pro is a little bit more dynamic. So sometimes you have to adjust your views a little bit to make sure that you're looking right at your site. So just by using these tools up here and the arrow keys, you can move around as you need to. And let's go ahead and also create a reference for scaling. If you come up here to the little tool, you'll see there's an add path, and you can basically bring in a path that has a certain dimension. So when you bring it into Revit, you can scale your image up and down by that path. So go ahead and click on it, pick a path. It doesn't really matter too much where you put it, just so that it's something that you can use to reference. Okay. And then next we'll go ahead and extrapolate a version of this scene that we're seeing. So go up to File, save, save image, and there'll be a little drop down that you can adjust the resolution, and there's a few map options that you can adjust how your view is displayed. I'm going to go ahead and keep on the 1080 HD. If you go any higher, it's going to take a while to export out, and it's going to take a little bit longer to work with in Revit. So let's just keep on 1080. Save image. We'll throw it on the desktop. I named it IMG01. Okay, let's switch back over to Revit and bring in our image. Go to Insert, Import Image, IMG01. Okay, and then we're going to use this line as a reference to scale to. So switching back to Google Earth, we can click on this line, go to the properties, and you'll say that's 382 feet. Go back to Revit. Let's draw a line 382. I'm just going to move my image to this line that we created so I can scale it. And we will use the geographical way to scale. And now that's pretty close. We can move it over to our site. And there we go. And you can see that the site is very close to where the pins are. And maybe adjust it here and there a little bit. But it's very close. Okay, next we're going to start to do some massing. So go up to the Massing and Site tab, and you're going to do you're going to do In Place Mass. Place Mass is a predefined mass that you bring in, but we're going to do it in place instead. Okay, keep it Mass 1. It's good to name your masses as you're creating different masses, but since we're basically doing one building forward, Mass 1's fine. And we've got some tools that we can use in order to create the different shapes of massing. We're just going to use a line tool. This doesn't have to be exact. And then once you create your form, you can hover over the form, make sure it's selected, and then you're going to create a form based off of that. So right now it's 2D, this makes it 3D. Okay, now you've created a 3D object. You can tell by the vector arrows here, and then you can just go ahead and finish off that mass. Okay, let's take a look at it in 3D, and there is our mass. Now you can see that I've created some additional levels. You can simply just click on these levels and copy them up as you want to create more levels. And I've also cleaned up the view a little bit by putting a section box in. We can create a pad. So go to a site plan view, go up to your Massing and Site, and do Building Pad. Come over to your pick line tools, hover over a line, then hit your tab, and you can click all lines at the same time. Now what I like to do is constrain these, click the little locks, so it's going to lock that pad to the mass. And we will finish that. And now go to a 3D view, and you can see that that pad has now cut into the site. And it's also come up and brought the topography up into the bottom of the pad that you've created. So now the bottom of your mass is also the top of the pad. And if you adjust one of these walls, you'll see that the pad moves with the wall. I should say mass. This is not a wall yet. Okay. Okay, next we're going to want to take our mass and divide it up into separate floors. So we're going to click on our mass and go to mass floors. And it'll give you the option of which floors you want to create. And you see now the mass has been divided up into each floor. And maybe you need to adjust your mass so that your floors aren't too far from the top. So you can just grab the grip and move it down. Or you could come and adjust the top elevation of the floor, the roof. Now that we've created our mass with our floors, we can start to put in our walls, our roof, and our floors. So to do that, you just come up to the floors and pick which floors you want to attach to. And you'll notice that it's set to the generic 12-inch floor. You can always come back and change those later. So then you can pick these floors. And now you've created all the floors. So next, we're going to do the roof. You select the top of the mass for the roof, create roof, and now you've created the roof. So now let's do the walls. Now for the walls, we're going to do something a little bit different. I am going to do, you can also do a curtain wall system or just walls. So let's do a curtain system, and we'll pick three of the walls, create system, and then we'll do the rest of the walls as a regular wall. Okay, now we've done massing to our first project. We've done a basic building, and you can see the curtain walls in there. And what's nice about doing these massing models is that if you want to adjust the mass, let's say that you're studying and you're like, okay, something needs to be moved in or out, or you've got too much area, floor area, then you can adjust the model. And there's a couple ways to do this. What's real powerful on the massing is that you can create schedules that show all the areas as well. So if you go to View and under Schedules, create a schedule for quantities. And then go to Floors. We're going to do Area, and that add from the left to the right. We're going to do Level, and then you can adjust. Let's move that up. So for now we're going to do Level and Area. So now you'll see that we've got 5 levels in the area of each level. Okay, so let's clean this up a little bit. I'm going to close my inactive windows. Go back to my schedule I just created. And I'm going to tile these so that we can see tile the the view so you can kind of see how this works. So if I want to move a face, now you can see that everything is turned on right now. It's hard to see my mass. So simply you can go to VG and turn off everything, select all, and turn off everything, but come back and turn the mass on. And now you'll just see the mass. And let's say that you want to adjust the design and the client wants to make part of this building smaller. And let's say they even want to reduce this end. Maybe we just make it a little bit bump out as a feature, and then the building needs to reduce in size. Okay. Let's go back to our visibility graphics. Go all, turn everything on. Now what you can do is, if you want to update your model, you can click everything, highlight everything, filter it so you're only seeing the walls. So let's uncheck everything except for walls. And then you'll see this little tab up here where you can update to face. And now it's just moved everything to the face of the mass. Now let's do that with the floors. So we'll filter out everything except for the floors, and then update to face. Same with the roof. There's only one roof, so we don't have to filter it, and then update to face. So now as you're working with your massing, you can adjust your building components to be updated with that massing. And let's say that you want to adjust the massing. Let's say this face right here, we want to do something different with it. I'm going to turn off everything just so we can see the mass. And let's do something different with this geometry. I'm going to tilt this face back. I should say these faces. Finish that mass. Visibility graphics and turn everything back on. And then I'm going to update the curtain wall. I need to do all the floors. So let's filter that for the floors. And then update to face. Still have to do the roof. Update to face. So you can see how the massing works to our benefit, and the levels in the areas it will update dynamically as you're adjusting your massing. So you can see as you go up in elevation for each level, the area of the footprint changes.